Now, for the industrial wastewater treatment, industrial wastewater, ito yung mga gamit na tubig. Waste, di ba? So, this is now the last topic. Introduction, industrial wastewater treatment covers the mechanism and processes used to treat waters that have been contaminated in some way by anthropogenic industrial or commercial activities prior to its release into the environment or its reuse. So, kailangan mo siyang i-treat para ma-reuse mo siya. If possible. Oh, wait. Most industries produce some wet waste, although recent trends in the developed world have been to minimize such production or recycle such waste within the production process. However, many industrial remain dependent on processes that produce wastewater. Hindi pa nila nire-recycle. So sources of industrial wastewater, one, mining, processing, chemicals. Meron siya. So number two, iron and steel industry. Discuss natin ito. The production of iron from its ore involves powerful reaction in blast furnaces. So cooling waters are inevitably contaminated with products, especially ammonia and cyanide. Production of coke from coal in cooking plants also requires water cooling and the use of water in byproduct separation. Contamination of waste stream includes gasifications, products such as benzene, naphthalene, antacene, cyanide, ammonia, phenols, cresols, together with a range of more complex organic compounds known collectively as polycyclic aromatic hydrocarbon, PAH. So sa water treatment mga terms yan. The conversion of iron or steel into sheet, wire, or rods requires hot and cold mechanical transformation stages, frequently employing water as a lubricant and coolant. Contaminants include hydraulic oils, tallow, and particulate solids. Final treatment of iron and steel products before onward sale into manufacturing includes pickling in strong mineral acid to remove rust and prepare the surface for thin or concreting or for other surface treatment such as galvanization or painting. Two acids commonly used are hydrochloric acid and sulfuric acid. Wastewaters now include acidic wastewater together with waste acid. Although many plants operate acid recovery plants, particularly those using hydrochloric acid, where the mineral acid is boiled away from the iron salt, there remains a large volume highly acid ferrous sulfate or ferrous chlorine to be disposed of. Many steel industry wastewater are contaminated by hydraulic oil, also known as soluble oil. So kaya sa steel iron and steel industry, yan ang magiging industrial wastewater mo. Sa mines naman, mines and quarries, yung mga quarrying, ito mining ang digging to ito sa labas. The principal wastewater associated with mines and quarries are slurries or black particles in water. Mga quarrying. This area arise from rainfall washing exposed surfaces and old roads, and also from rock washing and grading processes. Volumes of water can be very high, especially rainfall-related arising on large sites. Some specialized separation operations such as coal washing to separate coal from the native rock using density gradients can produce wastewater contaminated by fine particulate hematite and surfactants. Oils and hydraulic oils are also common contaminants. Wastewater from metal mines and or recovery plants are inevitably contaminated by the mineral present in the native rock formation. Following crushing and extraction of desirable minerals, undesirable material may become contaminated in the wastewater. For metal mines, this can include unwanted metals such as zinc and other materials such as arsenic. Extraction of high-value metals such as gold and silver may generate slimes containing very fine particles and where physical removal of contaminants become particularly difficult. collecting sample mine wastewater effluent with neutralized pH from tailing runoff. Palabas na. 4. Food industry. So, yung mga restaurant. So, wastewater generated from agricultural and food operation has distinctive characteristics that set it apart from common municipal wastewater managed by public or private sewage treatment plants throughout the world. It is biodegradable and non-toxic, but that has high concentration of biochemical oxygen demand, BOD, and suspended solids, SS. The constituent of food and agriculture wastewater are often complex to predict due to the differences in BOD and pH and influence of vegetable, fruit, and meat products and due to seasonal nature of food processing and post-harvesting. Processing of food from raw materials require large volume of high-grade water. Vegetable washing generates waters with high loads of particulate matter and some dissolved organic. It may also contain surfactants. Animal slaughter and processing produces very strong organic waste from body fluids such as blood and gut contents. This wastewater is frequently contaminated by significant levels of antibiotics and growth hormones from the animals and by a variety of pesticides used to control external parasites. Insecticide residues in fleeces is a particular problem in treating water generated in wool processing. Processing feed food for sale produces waste generated from cooking, which are often rich in plant organic material and may also contain salt, flavorings, coloring material, and acids or alkali. Very significant quantities of oil or fats may also present. Yan. Mapagluluto nyo. Kaya dapat iiwas yung luto nyo. Sa mga tira-tira, iiwas nyo sa maliliit sa tubig. 5. Complex organic chemical industry. So, a range of industries manufacture or use complex organic chemicals. These include pesticides, pharmaceuticals, paints and dyes, petrochemicals, detergents, plastics, paper pollution, etc. Wastewaters can be contaminated by feedstock materials, byproduct material in soluble or particulate form, washing and cleaning agents, solvents, and added value products such as pesticides. Treatment facilities that do not need control of their effluent typically opt for a type of aerobic treatment, that is aerated lagoon. Number 6, nuclear industry. So the waste production from the nuclear and radiochemical industries is dealt with as radioactive waste. Number 7, water treatment. Water treatment for the production of drinking water is dealt with elsewhere. Many industries have a need to treat water to obtain very high quality water for demanding purposes. Water treatment produces organic and mineral sludges from filtration and sedimentation. So ion exchange using natural or synthetic resources remove calcium, magnesium, and carbonate ions from water. Ito na hardness. Replacing them with hydrogen and hydroxyl ions. The generation of ion exchange columns with strong acid and alkali produces a wastewater rich in hardness ions, which are readily precipitated out, especially when in admixture with other wastewater. So, yan. Ito yung mga sources of industrial wastewater. The next, how to treat brine. Brine treatment involves removing solid salt, removing dissolved salt ion from waste stream. Although similarities to seawater or brackish water desalination exist, industrial brine treatment may contain a unique combination of dissolved ion, such as hardness ions or other metal, necessitating specific processes and equipment. Brine treatment systems are typically optimized to either reduce the volume of the final discharge for more economic disposal, as disposal costs are often based on volume, or maximize the recovery of fresh water or salt. Brine treatment system may also be optimized to reduce electricity consumption, chemical usage, or physical footprint. Reverse osmosis may not be viable for brine treatments, hindi pwede, due to the potential for fouling caused by hardness, salt, or organic contaminant or damage the reverse osmosis membrane from hydrocarbon. Evaporation processes are the most widespread for brine treatment as they enable the highest degree of concentration as high as solid salt. They also produce the highest purity effluent, even distillate quality. Evaporation processes are also more tolerant of organic, hydrocarbon, or hardness salt. However, energy consumption is high and corrosion may be an issue as the prime mover is concentrated salt water. As a result, evaporation systems typically employ titanium or duplex stainless steel material. Next, solids removal. Bilang to, walisin mo lang, ha? Most solid can be removed by using sedimentation technique with the solids covered as slurry or sludge. Lulubog lang siya. Para mga septic tanks, di ba? Pag yung mga sedimentation tank, yung mga solid niya, doon sa baba may iwan, yung liquid sa taas, dumadaan lang. So very fine solid and solids with densities close to the density of water pose a special problem. In such case, filtration or ultrafiltration may be required, although flocculation may be used using alum salt or addition of polyelectrolytes. Sa water treatment to, civil, meron sa dito. Sa atin, yung mga equipment lang pamimotor, so kaya may alam din tayo sa water treatment. Wala na ngayon. Kailangan ng discharge permit ng water treatment, environmental air pollution, solid waste water management, and yung mga engineer na yan. Oil and grease removal. So, meron tayong tatawag sa mga kusina ng grease trap para hindi lobas yung langis doon sa drainage. Many oils can be recovered from open water surfaces by skimming devices. So, lumulutang yan. Considered a dependable and safe way to remove oil, grease, and other hydrocarbon from water, oil skimmer can sometimes achieve the desired level of water purity. At other times, skimming is also cost-effective method to remove most of the oil before using membrane filter and chemical processes. Yung parang winawalis mo yung oil sa igbabaw ng tubig. Lumulutang siya, di ba? Yan. Skimmers will prevent filters from blinding prematurely and keep chemical costs down because there is less oil to process. Because grease skimming involves higher viscosity hydrocarbon, skimmers must be equipped with heaters powerful enough to keep grease fluid for discharge. Kasi parang lumabnaw. If floating grease forms into solid clumps or mat, a spray bar, aerator, or mechanical apparatus can be used to facilitate removal. However, hydraulic oils and the majority of oils that have degraded to any extent will also have a soluble or emulsified component that will require further treatment to eliminate. Dissolving or emulsifying oil using surfactants or solids usually exacerbates the problem rather than solving it, producing wastewater that is more difficult to treat. So the wastewater from large-scale industries such as oil refineries, petrochemical plant, chemical plant, and natural gas processing plant commonly contain gross amount of oil in suspended solids. Those industries use a device known as the API oil water separator, which is designed to separate the oil and suspended solid from their wastewater fluent. Sa mga kasalinan, meron din ito. Oil water. Pasok dito, tapos yan. Labas doon. So yung oil sana sa taas na. So ito, punta doon. Discuss natin. The name is derived from the fact that such separators are designed according to standard published by American Petroleum Institute or API. The API separator is a gravity separation device designed by using Stokes law to define the rise velocity of oil droplets based on the density in size. The design is based on the specific gravity difference between the oil and the wastewater because the difference is much smaller than the specific gravity between the suspended solid and water. The suspended solid settles at the bottom of the separator as a sediment layer. One, thrust up to retention bubbles through distributors. So check niyo yung mga books na wastewater. Pour or layer, yan. Slatted pipe. Skimmer, so papasok doon. Oil. Slab something. And light scraper. So ito, scraper sa mga bagsak dito. So, typically, the oil layer is skimmed off and subsequently reprocessed or disposed of, and the bottom sediment layer is removed by chain and light scraper. Ito. And a slab pump, kung meron pang nahulog dyan. So the water layer is sent to further treatment consisting usually an electroporation module for additional removal of any residual oil and to some type of biological treatment unit for removal of undesirable dissolved chemical compound. So next type is the parallel separators. Parallel plate separators are similar to API separators, but they include tilted parallel plate assemblies, also known as parallel packs. The parallel plate provides more surfaces for suspended oil droplets to fall into large globules. Such separator still depends upon the specific gravity between the suspended oil and the water. Ayan na. So dito. Ang gawin ng mga oil andun tumataas. Okay. So, however, the parallel plate enhances the degree of oil-water separation. The result is that a parallel plate separator requires significantly less space than a conventional API separator to achieve the same degree of separation. So, yung mga design nito, natin naman yung mga theory sa internet natin o sa book ng mga water treatment. Next, removal of biodegradable organics. Biodegradable organics of plant, material of plant or animal origin is usually possible to treat using extended conventional sewage treatment processes such as activated sludge or trickling filters. Problems can arise if the wastewater is excessively diluted with washing water or is highly concentrated, such as undiluted blood or milk. The presence of cleaning agent, disinfectants, pesticides, or antibiotic can have detrimental impacts on treatment process. So ito yung activated sludge process. These are activated sludge is a biochemical process for treating sewage. An industrial wastewater that uses air or oxygen and microorganisms to biologically oxidize organic pollutant, producing a waste sludge or flake containing the oxidized material. In general, an activated sludge process includes an aeration tank where air or oxygen is injected and thoroughly mixed with wastewater. A settling tank, usually referred to as gasifier or settler, to allow the waste sludge to settle. Part of the waste sludge is recycled to the aeration tank and the remaining waste sludge is removed for further treatment and ultimate disposal. So check yun yung mga STP, ganun din ang mga process niya. Next, trickling filter process. Yeah. A trickling filter process consists of a bedrock, so gravel, yun, media, gravel, slag, peat moss, or plastic media over which wastewater flows downward and contacts a layer or film of microbial slime covering the bed media. So aerobic conditions are maintained by forced air flowing to the bed or by natural convection of air. The process involves absorption of organic compound in the wastewater by slime layer, diffusion of air into the slime layer to provide the oxygen required for biochemical oxidation of the organic compound. The end products include carbon dioxide gas, water, and other products of the oxidation. As the slime layer thickens, it becomes difficult for the air to penetrate the layer and an inner anaerobic layer is formed. This is the schematic cross-section of the contact phase of the bead media in a trickling filter. So the fundamental component of a complete trickling filter is a bed of filter medium upon which a layer of microbial slime is promoted and developed. An enclosure or container which houses the bed of filter medium. Then a system for distributing the flow of wastewater over the filter medium. And a system for removing and disposing of any sludge from the treated effluent. So the treatment of sewers or other wastewater with trickling filter is among the oldest and most well-characterized treatment technologies. A trickling filter is also often called trickle filter, trickling biofilter, biological filter, or biological trickling filter. Treatments of other organics. Synthetic organic materials, including solvents, paints, pharmaceutical, pesticides, cooking product, and so forth, can be very difficult to treat. Treatment methods are often specific to the material being treated. Methods include advanced oxidation processing, distillation, adsorption, vitrification, incineration, chemical immobilization, or landfill disposal. Some materials, such as some detergents, may be capable of biological degradation, and in such cases, a modified form of wastewater treatment can be used. Acids and alkalis can usually be neutralized under controlled conditions. Neutralization frequently produces a precipitate that will require treatment as a solid resid that may also be toxic. In some cases, gases may be evolved requiring treatment for the gas stream. Some other forms of treatment are usually required following neutralization. Waste stream rich in hardness iron as from the deionization processes can readily lose the hardness ions in a build-up of precipitated calcium and magnesium salt. This precipitation process can cause severe pouring of pipes and can, in extreme cases, cause the blockage of disposal pipe. So a 1-meter diameter industrial marine discharge pipe serving a major chemical complex was blocked by such salt in the 1970s. Treatment is by concentration of the ionization wastewater and disposal to landfill or by careful pH management of the released wastewater. Toxic materials, including many organic materials, metals such as zinc, silver, cadmium, thallium, etc., acids, alkali, and metallic elements such as arsenic or selenium are generally resistant to biological processes unless very dilute. Metals can often be precipitated out by changing the pH or by treatment with other chemicals. Many, however, resistant to treatment or mitigation and may require concentration followed by landfilling or recycling. Dissolved organic can be incinerated within the wastewater by advanced oxidation process. So, yeah. So this is the end of the industrial wastewater treatment. Thank you very much.